Hi, grade 9s. Welcome to Exponent Laws, the first Exponent Laws section, which is 2.4 in your workbooks and in the textbook. Patterns arise when we multiply and divide powers with the same base. So mostly when we're doing exponent laws, we're probably dealing with multiplication and division of powers. We did addition and subtraction in 2.3, so I think we've got those covered. Now we're looking at multiplication and division. So for instance, let's say if we're going to multiply -7 to the power of 3 by -7 to the power of 5, if the integer base is the same, in this case it is -7 and -7, those are our bases, we can actually do some pretty simple math so that we don't have to punch this all out in a calculator, in which case we would probably get the wrong answer. You know, we might put in too many -7s or not enough, or get confused in our multiplication statement. So there's an easy way that we're going to deal with these, and that's what we're talking about today. The base of the product is -7. We can see that's the base in both of these. And the exponent, well, we've got two exponents right now. We've got a 3 and we've got a 5. But if we look at the final answer, now this person did put it into a multiplication statement. All right. 1, 2, 3, 4, 5, 6, 7, 8. Okay. It's -7 to the power of 8. All right. So the sum of the exponents in the power is 8. Sum, okay, is addition. Look at the number of -7s. There's 8 of them. But look at our original question. We've got a 3 here, and we've got a 5 there. Okay, so if we look at our exponents when it comes to multiplication, we get the right answer by adding them. So that makes it so much easier to find the answer in these. Instead of having to do all the multiplication down here and figure it out the long way, we could just look and say, well, if this is -7 and this is -7, and it's multiplication, all we need to do is add the two exponents. 3 plus 5 equals 8, and we can jump right to the final answer. Okay, so the final answer here is -7, and let's make sure we include the brackets here, and I probably should include them here because they are important, and to the power of 8. So we can just jump right from the original question right to the answer as long as we understand our exponent laws with regard to, in this case, product, which is multiplication. Okay, so remember, product is multiplication. Now this is just sort of taking care of the general case. A is any number except for 0. So it doesn't matter if it's 2, or 3, or 4, or 5. As long as it's the same here and here, okay, a to the power of m can be any number, and n can be any number. Okay, so let's just take an example over here. Let's just say that a equals 2, okay, and let's say m equals 3, and let's say that n equals 5. All right, if we were to have a question that said, okay, a to the m, so 2 to the 3, times, and I don't like the x, I like the dot, 2 to the 3 times, well, a is still 2, and n is 5. Okay, what that's saying is that's going to be 2, because that's a, to m plus n. So that's going to be 3 plus 5, which means our final answer is going to be 2 to the power of 8. So that's an example of what this means. Okay. Now dividing, okay, division is the inverse operation. Think of that as the opposite operation of multiplication. Well, in multiplication we used addition, so logically, for division, we're going to use the opposite of addition, which is subtraction. Okay, so exponent law with products of powers, products, is plus, and then with division, it's going to be minus. So we're going to subtract the powers, and I think you'll see how that works out when I just go through this example here. So if we're going to divide 8 to the power of 7 by 8 to the power of 4, okay, we can do all the math if we want, but instead of doing all this math, okay, why don't we just skip the whole process and go from here to here in one step using subtraction? Okay, so what we really can do, I mean, you can go through all this, and we know you can cancel from top to bottom and whatnot. You'll get the right answer. But if we know that the law with regarding to division is subtract the powers, we can go 8 okay, to the power of 7, divide by 8 to the power of 4, we could just take these two, because the 8's the same, we can just do 7 minus 4 equals 3. Then we can just skip right to the answer. A to the power of 3. Okay? So why make it any more difficult than it needs to be? For multiplication, you're going to add the powers. For division, you're going to subtract the powers. All right, in this case, this is probably just going to reiterate what I just said. The base of the quotient is, that's the 8, correct? The exponent for the answer is 3. Okay, the difference is subtraction, of the exponents of the powers that were divided is 3. Just like we did above. Erase these little marks. All right, let's move on to the official explanation. Very similar to what we did for multiplication. Quotient is division, right? Okay, so for the quotient of powers, division, a to the m divided by a to the n equals a to the m minus n. Now let's just use the exact same example we did before. A is 2, m was 3, I believe, and n was 5. Okay, so if we do that, then what we've got is, okay, maybe I'll just put this over here. What we've got is a to the power of m, so that's 2 to the power of 3, okay? And then we've got divided by 2 to the power of 5. We're going to get a negative number on this one, that's okay, equals 2 to the power of m minus n. Okay, so that's the m, that's the n. Okay? So in this case, our final answer is going to be 2. 3 minus 5 is negative 2. It's going to be 2 to the negative 2. Now, we haven't dealt with negative exponents yet, so I'm not going to go too far into that, but the important part is that you get the right number up there. Okay, now let's write each expression as a power, knowing what we know about multiplication and division. Okay, so this one's multiplication. Let's keep that in mind. So for multiplication, it's going to be 6, and then we've got to add these to the power of 5 plus 4. So our final answer is 6 to the power of 9. Now, we don't need to actually find out what 6 to the power of 9 is. It just says write it as a power. So that's what we're doing. Remember, we can only do this if the bases are the same. In this case, the bases are both negative 9. Okay, so that's important. So you can always write the negative 9. Okay, so it's going to be negative 9. Okay, and then we've got 10. Now this time it's division, so we have to subtract 10 minus 6. So the final answer is negative 9 in brackets to the power of 10 minus 6 is 4. So you see, there's not a lot of math in this. Even though we could be dealing with big numbers, 6 to the power of 9 is a very big number. Punch it in your calculator if you don't believe me. 6 times 6 times 6 times 6, 9 of them, right? But if we're writing it as a power, it's just simple math. It was just addition. Okay, so now we're going to do a few more here. This time we are going to evaluate, which means that we're not just going to take it down to the power like we did here. We're actually going to solve for a final answer. All right, so let's evaluate. Negative 2 to the power of 4 times negative 2 to the power of 7. Okay, so we got to do, we know they have the same base, so that we might as well write the negative 2, because we know we're going to use that. And because this is multiplication, we're going to add the exponents. 4 plus 7 equals 11. Now, if we're going to evaluate, we actually have to take this down to the final standard form. So I can't remember what negative 2 to the power of 11 is, but I do know that it's going to be a negative because there's an uneven amount of negative signs. So I'll just take the calculator here. The power of... find my power button. My power button. Oh, there it is. 11. Sorry, I had a little trouble finding the power button on my calculator. So many buttons. In any case, the power of 11 is 2048. So our final answer there is negative 2048. We'll use a similar process on the next one here. We've got 3 to the power of 2 times 3 to the power of 4 divided by 3 to the power of 3. Let's just do this one step at a time. So let's just do this one's first, and then we'll worry about this one second, okay? So we've got 3 to the power of 2 times 3 to the power of 4. Well, we know the base is the same, so let's just write the base. And then because it's multiplication, it's really plus the exponents. 2 plus 4, so that's going to be 3 to the power of 6. Then divide by 3 to the power of 3, We also have a rule for that, right? It's division, so we can subtract the exponents. So that's going to be 3 to the power of 6 minus 3 equals 3 to the power of 3. So that's 3 times 3 is 9 times 3 more equals 27 as our final answer there. A few more. So these are also evaluate, so we will first take it down to powers, and then we'll take it all the way to the standard form. This one we've got addition and multiplication, so we have to use our order of operations. All right, but let's do all the, excuse me, the base is the same. So we're going to just leave 6 squared for now, because we know we're going to do the multiplication next. And this time we're going to do 6 to the power of 3 times 6 to the power of 2. Well, the base is the same, it's just 6. And then because it's multiplication, we're going to add those two, and we get that. Now this is a common place where students will make an error where they'll add these exponents again. But look, we've got addition. We don't have multiplication, so we actually can't use those exponent laws. We actually have to solve it. So 6 squared is 36, plus 6 to the power of 5. That's a really big number, so I'm going to punch that into my calculator. 6 to the power of 5 is 7776. For a final answer, now we just do the addition of 7,812. All right, so we did everything we could to get to this point, but after that, you've just got to put it into standard numbers, standard form. Okay, B. There's some brackets in here, and luckily enough, most of our exponents are negative 10, but we have to be a little bit careful here because we don't have brackets including the negative signs. So let's just kind of be aware of that. All right, so we got to do what's inside the brackets first. So I'm just going to leave this negative 10 to the power of 4 there. And let's look at what's inside the brackets. We've got division, which means we can subtract the exponents because the base is the same. This only works if the base is the same. So in this case, I'll just put a bracket here because it's going to be multiplication. So we've got negative 10 here to the power of, negative 10 to the power of 6 minus 4 is 2. And then on the back end of that, we've got negative 10 to the power of 7. All right, let's just keep working through this. We know we've got to do multiplication before we do subtraction. So our base is still negative 10 here. And then we've got multiplication. These two are back to back, so that's multiplication. And we know for multiplication, we can just add the exponents. So that's going to be 10 to the power of 6, right? 4 plus 2. And then we've got minus 10 to the power of 7. Okay, so we got to be a bit careful here. We can't work any further with these exponents because they're different bases. They look the same, but they are not the same. The brackets around this negative 10 means that the exponent 6 must apply to everything inside the brackets, which includes the negative sign. However, over here, we don't have brackets around the negative sign because it's a subtraction question. So this 10 is different than a negative 10, right? Negative 10 base here and 10 base here. So we actually can't do anything else until we put these into numbers. Okay, so our standard form. So we've got a power of 6 here, so we know our answer is going to be positive, right? Because there's an even number up here as the exponent. So then when we're working with tens, we know that's pretty simple, right? We just put a 1, and then we're going to need 6 zeros. 1, 2, 3, 4, 5, 6. And then this one's also easy, okay? Because you've got a 1 and then 7 zeros this time. 1, 2, 3, 4, 5, 6, 7. So our answer is going to be negative here because this number is bigger than this number. So that is 1,000,000. 1, 2, 3, 4, 5, 6. Subtract 1 with 1, 2, 3, 4, 5, 6, 7 zeros, and we are left with a number that is negative 9 and 6 zeros, which is negative 9 million. So that should take care of your exponent laws for multiplication and division. And just one thing to keep in mind, always keep in mind you have to be working with the same base when you're dealing with these exponent laws. So it only works when you've got the same base. In this case, negative 10 here, negative 10, negative 10. If these were all different numbers, or in this case, if it didn't have the brackets around the negative sign, you can't go any further with the exponent laws, and you'll just have to take it to standard form. All right, the next video is going to be on 2.5, and best of luck with this.